So I just want to finish off the slides there, as I mentioned in the message to you yesterday, because it actually comes into the first assignment. If you remember, there's one aspect of one of the grading spectrums where I mention code splitting, which I haven't actually spoken about yet, as it turns out. But so let's see. So Webpack is the tool that we're talking about, but in the context of CI/CD, it's all about the build job within a CI/CD pipeline. And you'll remember from the last day, this is kind of a visualization of what Webpack does. It takes all of your source code, and your source code is, I'm representing it here on the left as a hierarchy of dependencies between the various modules that make up your source code. It takes all of that and it converts it into a single entity on the right, which we call a bundle. And that bundle contains all of our JavaScript code. It has been transpiled. So for example, if the thing on the left is a React app, it takes all the JSX and converts that into plain old JavaScript. Or if it's TypeScript or CoffeeScript, which are other forms of JavaScript, it also converts those or transforms those into ES5 JavaScript. In fact, it's a bit more sophisticated than that. Even if the modules on the left include other types of files as well, in particular CSS, and the CSS files could be in different forms as well. It could be in the form of a less file or a SAS file. It'll take those particular entries on the hierarchy on the left, and it'll package those into a single bundle as well. So now we see on the right that we could have a number of JavaScript bundles. We'll see in a moment how we actually control how many JavaScript bundles are created on the right-hand side. But as well, we'll see on the right there, we see on the right that there is a bundle that just contains CSS. And if you've got a number of images that make up static images that are part of your dependency hierarchy, it'll put all of those images into a bundle on their own as well. You can actually control that. Sometimes you may not want the separate bundles for your CSS and your images. You actually want those included in the JavaScript bundle, and Webpack can take care of that as well. So that's the idea behind Webpack. Now, we talked then about the whole area of kind of optimization in relation to this whole bundling process. And by optimization, what we're getting at there is we want the initial load time of our application into the browser to be as quick as possible. And one way we can control that is to have the initial JavaScript bundle that is sent down to the browser when the user loads the application into the browser. Try and keep that initial JavaScript bundle as small as possible, because it takes less time to be transported over the web, obviously, and it takes less time for the browser to kickstart it. So that's really what we're trying to achieve when we talk about optimization. That's one aspect of it anyway, one aspect of optimization. So when we talk about, I got to here, yeah. Bundling for production. So the kind of things, as I said, as I mentioned last day, is one thing is you want to minimize the size of your bundles, and fortunately Webpack takes care of that. It performs minimization. I spoke about that the last day, and I briefly talked about uglification, but it's minification, I suppose, is probably the more important of those two. Caching is where I left off. How can we avail of caching in the context of this whole area of web app bundling? And so so the first thing we need to know about is when Webpack creates a bundle file for us, it actually follows a naming convention, and the naming convention is based on hashing. So what I'm saying down here is that the bundle files, the actual part of the name of the bundle file is a hash value that is computed by Webpack. And that hash value is computed based on the contents of the bundle file itself. We don't have to care about how it computes that. It's just that it is. So that the fact that part of the file name is a hash and that hash is computed from the contents of the file, that becomes very useful to us and to the browser in order to control caching. So, so over here, for example, I'm showing you an example of a bundle file name that's generated by Webpack, and this part here is the hash value. Now, so taking that on board, what I'm describing here is your typical interaction between the browser and your web server. The web server on the right is responsible for hosting your web app. So your typical flow of control might be the browser, the user navigates to your web app. So the request is sent to the server for the web app, and the initial response that comes back is the index.html file. In that index.html file, there will be a script tag referring to the bundle file. And so the browser now requests the bundle file. And the bundle file comes back. And let's supposing this is my bundle file name. So 1234 here is the hash value, let's say, for this particular bundle file. And it is represented, it is computed based on the contents of the bundle file. Now, the browser will actually, as well as execute the contents of the bundle file, it will store that bundle file in its local cache as well. As we know, browsers have caches built into them. So it caches that bundle file. At some time later on, the user navigates to this web app again. So the browser is going to make a request for the web app to the same server. The server has to return the index.html file. That's always going to happen. But what the browser will now notice is that in the index.html file, it is referring to the same bundle file that it has already cached up here. And we are assuming now that the developer has not made any changes to the web app. Therefore, the bundle file will not have been changed. So now the browser realizes, I need bundle 1234, but I already have it. So I don't need to request it from the server. And obviously it will execute the bundle file and load or render the application back to the user. So obviously that has speeded things up. We haven't been delayed by the need to request the bundle from the server. So that's where caching comes into play here, and that's caching has been facilitated by the fact that the bundle file contains this hash value, and Webpack takes care of computing this hash value, and we know what the hash value is computed from. If, let's say over here that I'm saying, let's supposing the developer does make some changes to the source code and will consequently generate a new bundle file, and let's suppose the new bundle file has 4567 as its hash value, then obviously when the user at some later stage wants to load this web app into the browser, they request the app from the server returns the index.html, but now the browser sees that the index.html is referring to a bundle file that it does not have in its cache, and so it has to request the bundle file at this stage, and the bundle file comes back. So, I suppose the upshot of all of this is that Webpack will supports this caching that I'm describing here for us anyway. by virtue of how it names the bundle files. We don't have to do anything to achieve that, but it's important just to be aware of it. So minification is one way we improve the initial load time. Caching is another way of improving the initial load time, albeit it's only beneficial here when the browser already has the bundle. The third part of optimization is code splitting. And as the name kind of suggests, what is going to be happening here is we're going to be splitting our source code up into multiple bundles. And I showed you that at the beginning of this lecture, that you can actually split your JavaScript code or indeed your CSS, but we're only interested in the JavaScript side. You can split it up into multiple bundles rather than just having it all packed into one bundle. And you do that, you the developer, controls that by leveraging this dynamic imports aspect of JavaScript. So what dynamic imports allow us to do is to split the app's custom code into multiple bundles. And then the idea is that the browser would only load the bundles. Bundles are also referred to as chunks, by the way. It only loads the bundles or chunks that it needs to render the home page. Any of the other bundles are lazily loaded, or they're loaded on demand. What we mean by this is that the other bundles are only downloaded from the server to the browser when the browser actually needs them, and that would be controlled by the user really. If the user navigates to a particular page, let's say in the app, and the source code and the bundle code required to render that page is not available yet, it's only then that the browser will actually request that particular bundle from the server. The reason we're doing this code splitting at all is to reduce the initial app's load time, as in reduce the size of the first bundle that needs to be sent down to the browser in order to render the home page. So to demonstrate this, and this comes up in the lab, I've got this simple little app. Again, it's based on the movies TMDB. So this is my home page, okay? And there is a button here. And if the user clicks the button, it's only then that the app displays the list of movies that is received from TMDB. So that means that the code that is required to generate this list of movies, that code isn't really required in order to render the home page. So the code that generates this list can be in a separate bundle that's only downloaded to the browser when the user eventually clicks this button here. As well, I have this other page, the movie details page. Okay, I'm just displaying the movie details as a JSON form because I'm not interested in the UI this side in this example. The code that generates the movie details page, that code isn't really required by the browser until the user decides to click on one of these movies. So we could put the code for this page into another bundle, and that bundle is only downloaded to the browser on demand, as in when the user actually requests to display this page. That's the objective, and that's how the app is going to work. So what we need to find out is, how do we actually split the source code? How do we split our bundle code into multiple chunks or multiple bundles? And the answer is we use dynamic imports. Before I talk about the technique, all I'm showing you here is just an excerpt from the home page, as we can see. And so what am I showing you? Well, I mean, this is just React stuff, which shouldn't be of any great surprise to you in terms of understanding. What I'm showing you here is I've got a state variable let's see, this state variable here, the state variable controls whether the list of movies is displayed on the home page or not. So it's initialized to false. And you can see here that I'm using the state variable down here to control whether this component should be rendered or should it just render null. This is the component here that generates this list of movies in the home page. I've also got my button here, and the button has an on-click handler, and all the on-click handler does is it toggles the state variable that I'm using. So it just changes the state variable from false to true or true to false. So that means when the user clicks the button the first time, that's going to change this state variable to, it's going to change it to, it's going to change it to true. It's initialized to false. It's going to change it to true. And we know that this component is going to re-render, but because this is now true, that means this component is now rendered, i.e. the list of movies are displayed. Now, the way you see the code at the moment, it doesn't support this kind of multiple bundling, as it turns out, but I'm just showing you the code without any bundling, multiple bundling happening. So that's how the home page works, and that's just a React thing. It's got nothing to do with Webpack or code splitting. That hasn't happened yet. Before I talk about dynamic imports, let's understand static imports, which is the only type of imports that you know about so far in relation to JavaScript. I'm saying static imports are resolved at build time. So when you do npm run build in context of React and the create React app tool, when you run a build, then Webpack will analyze all of these static import statements, and it uses these static imports to decide what should go into the single bundle that it's going to create. It's only going to create one single bundle. So I'm saying here the Webpack bundles the entire app's code, including the node modules, by the way. It packs them all into a single bundle, which in Webpack terms we just refer to as the main bundle. Okay, so that's the case when we just have static imports, only one bundle, and everything is packed in there. And we see evidence of that in our build folder here on the right. We can see that there is a single JavaScript bundle. There happens to be a single CSS bundle as well, and that's only because I decided that I would do a tiny bit of styling on the button, and the only reason I did some custom styling on the button is in order to show you that there is a separate CSS bundle generated by default by Webpack in the context of the Create React App tool. But our focus now is on the JavaScript bundle, and there's only one, as we can see here in the build folder. What I'm showing you here is a screenshot of when I actually run the app, and you will do that in the lab. When I run my app, now bear in mind now I'm running the app using a standard HTTP web server, and what I'm serving is the build version of the app. I'm not running the Create React App's own built-in web server. It's a separate standard web server. So I've gone away and I've created my build folder. I've generated this build folder, and I've started off a standard web server, and I've pointed it at this build folder. So that is the app that it is serving. That is the code that it is serving to the browser. So when I navigate to and I've decided that my web server is running on port 8080 up here. So when I navigate to localhost 8080, this displays on the screen, but what we're really interested in is what is happening over here. What I'm showing you on the right is the developer tools, and I'm showing you the network tab in the developer tools. And we can see that it has indeed downloaded the main bundle, the main JavaScript bundle, and by the way, the main CSS bundle. The main JavaScript bundle will contain all of the node modules and our custom code, which has been transpiled into ES5. The other stuff then is just standard kind of stuff. So that's what happens when all of our import statements in our source code are static imports. How do we implement dynamic imports? And this is now specific to React, as it turns out, but dynamic imports are part of JavaScript, but React has a way of implementing them. The thing about dynamic imports I'm saying is that they're resolved at runtime. So it's only when, what I mean by resolved at runtime is that when there is a particular piece of JavaScript code executed in the browser, and that JavaScript code execution refers to a bundle and, refers to a module, and that module is associated with another bundle, then the browser will request that bundle from the server. It's actually resolving it at runtime, which was not the case when we had static imports. Static imports, we just had one bundle, and every import statement, as the browser came across it, as it was running our code, the import statement was referring to a piece, was referring to a module, but that module was already part of the bundle that it already has available to it. Whereas dynamic imports are work slightly differently. So they're resolved at runtime. The way we implement dynamic imports is by using this special function provided by React called lazy. So you'll see here actually me using it. So here I'm actually importing, I'm in my home page and I'm importing the filtered friends. Is that the one I'm importing? The filter movie list. I'm importing that in a dynamic way rather than a static way. Okay, the code is just different, we can say for now, right? And I'm using the lazy function to do that. So that's how I code my dynamic imports. Instead of the static import, I'm coding it this way. But I can use this in the rest of my code in the normal way. So filtered movie list is a reference to a component, just as, well, there are no other components here as it turns out, but it's just a component reference. Now, by virtue of the fact that I'm using dynamic imports here, that means that what happens when I run my npm run build is that the Webpack is actually going to generate a second JavaScript bundle for me. And in that second JavaScript bundle, which is this one here, inside in that bundle is the code associated with this JavaScript file. Okay, so that's that. So now I have two, and let's supposing this is the only place that I'm using dynamic imports in my source code. So I can be assured that this second bundle will just contain the component code associated with this component and any subordinate components that it has, by the way. So it may have child components as well. That are packed into this second bundle. I still have my main bundle, of course, down here. Is that my, yeah. Now, the story doesn't end there though. Because we're using dynamic imports, where we actually use the dynamically imported component down in the body of our homepage, we have to wrap that component reference. And this is the line of code that I showed you earlier on. Okay, so this line of code hasn't changed, but I've brought in this new wrapper component called the suspense component. So we have to, anywhere we have a dynamically imported component in our source code, when we use that component, we have to wrap it inside this suspense component. And that is because this component now here is not going to be immediately available to my home page when my home page wants to render. When my home page wants to render, I'll just repeat that, when the home page needs to be rendered, this component here is not going to be immediately available to the browser because it's in a separate bundle, and the browser has to request that bundle. It has to be downloaded from the server to the browser, and only then can the browser actually render whatever this component wants to put on the screen. So the question is, what happens in the meantime? Does the browser freeze waiting for this second bundle to be downloaded? And the answer is no, it doesn't. What it does is it displays whatever the suspense component tells it to display by virtue of this fallback property. This fallback property can be assigned just a piece of ordinary HTML. You can actually assign it to another component, provided that other component is statically imported or is already available to the browser. So that's the function of this suspense component. It tells the browser what to display on the screen while the browser is waiting for this additional bundle to be downloaded from the server to it. Right, am I missing anything? So the lazy component, okay, that's all right. Which okay, yes, now that you can place, yeah, you can place the suspense component anywhere above the lazily loaded component. So, you know, I could have actually taken the suspense component and brought it way up here. And obviously then its closing tag would, well, it's actually closing tag could stay where it is. So I can, you know, I can wrap as many components as I want to inside a suspense component. And all of the components that are wrapped by the suspense, all of them do not have to be dynamically imported. Only one of them has to be. It made sense to put the suspense component here in this case because you know, it fits naturally, but you're not constrained in that way. What it now means is that because I'm now using dynamic imports, it now means that when I load my app into the browser, okay, all that renders initially is this code here, or is this is what is rendered on the screen. I don't see my list of movies. And we saw what happened. So the main component will be downloaded, which you can see here. Sorry, where is it? Here, sorry, yeah. So the main bundle, sorry, keep mixing my words. The main bundle is downloaded initially, and it's the code in the main bundle that allows the browser to generate this on the screen. By the way, the main bundle will also have all of the node modules. We can't control that. But it's not until the user clicked the show movies button, it's only then that this additional bundle is downloaded. And you would see that happening. Maybe I should just maybe show it. So here's the app, and I've already generated my build. Now, as it turns out, I've got more than one instance of dynamic imports happening in my source code, but that's okay. That's why I've got a number of bundles here. I've got this bundle, and So I've got this bundle and I've got this bundle. And I thought I had a third one. Oh yeah, I've got, no, I've only got two bundles, it turns out. I thought I had a third one. But if I just run my app, now I'm not running it using the Create React App Server. I'm going to run it using this additional little script that I have in my package.json. So I've installed a separate web server called HTTP server, which you will do in the lab as well. And if I start off that server like so, and then go to localhost, there's no live reloading or any of that going on now because we don't have that benefit. This is a production environment, Maria. So I go to, and I open up my developer tools, and I happen to be on the network tab. So if I just do a manual refresh, okay, this is what we talked about. This is what's downloaded from the server to the browser. I'm only interested in this one. But now if I click this button, my list of movies will display, but notice here, an additional bundle will be downloaded. So if I go, there's my new bundle that has been downloaded. Now, because there's very little happening in terms of the volume of source code is minimal, that fallback that I mentioned in the suspense component, remember I said that the suspense component specifies what should be displayed while it's waiting for the additional bundle to be downloaded. We don't see that because it's happening so quickly, but it does if it does work. Can I just go back to my bundled, my build folder again? Okay. So right, you saw that in action. So you saw the fact that the additional bundle was downloaded on demand, or it was downloaded lazily, as we say. One of the main aspects of an app where code splitting is applied is in the roots parting part of your app. So we have this notion of root-based code splitting. So if we take this kind of generic example here, so I've got this app and it's got 3 roots associated with it, where presumably this is the home root. So that would mean, and these circles are the components that make up my application. What it would mean in the context of this generic application is that the only source code that needs to be downloaded in a bundle to the browser initially is this component, this one, and this one. So we should be able to create a bundle, or our main bundle should only contain those components from our app. It will, of course, include the node module stuff as well. But in terms of custom code, that's all that's required in the main bundle. And we should create another bundle that contains those components on the left, a third bundle that contains the components on the right. And that would be the most we can get out of splitting our bundles up into sub-bundles. And the way we do it is really the same as I've already shown you in the earlier example. Let's see. Yeah, so for example, I'm lazily importing going back to our sample app, I'm lazily importing the movie details page. Okay, which is fine. And then in my routing configuration, I refer to the movie details page in the normal way in a root entry, but notice all of my routes are wrapped inside a router, And I'm using my suspense component to wrap all of the routes. And this is what I was talking about earlier on. You can have the suspense component wrap multiple components. So the effect now is that whenever the user navigates to this route, the component, because the component that it renders has been lazily imported or dynamically imported, it means there's going to be a separate bundle that contains this movie details page. That movie details page is not going to be immediately available to the browser whenever the user decides to navigate to this path. So it needs to be downloaded. And while the browser is waiting, the suspense component says, just display that on the screen while we're waiting for the additional bundle to be downloaded. And again, you will implement this code splitting at the root-based level in the lab accompanying this set of slides. And so what it now means is that when eventually the user navigates to the movie details page, and they do that by clicking one of the movies in the movies list, it's only then that the third component in my sample app is actually downloaded to the browser. I'm confused as to why I can't see that actually. I'm still going back to here. Okay, I may have run my build before I actually implemented the third example of code splitting. But the general idea, you'll see it in the lab anyway. You'll see this happening. So that's root-based code splitting, which is by far and away the most common application of code splitting in a React app. And indeed, if you had nested routes, which I'm kind of demonstrating here in a generic way, those nested routes could be in separate bundles as well. So there's, depending on how sophisticated your app is in terms of the different types of routes, main routes and subroutes, you have lots of opportunities to avail of code splitting. Something that we'd like to be able to do is to be able to see inside a bundle and get a sense of which modules, be they our custom modules, our own JavaScript code, or modules from the node modules folder, which modules contribute to a particular bundle. And we can actually do that because there is a tool called a source map explorer. And again, you use this in the lab. So the source map explorer, it essentially uses those map files. If I go back to, I mentioned these before, or at least I mentioned them the last day. These map files here. The source map explorer can use these map files, and what it does when it analyzes a map file is it generates this kind of visualization of the contents of a bundle in terms of the various modules that make it up. And it also shows you how much of the bundle size is contributed to by each module. I don't know if you can see it there or not, but it tells you the size of each of these modules within the overall bundle size. The overall bundle size is sort of up here. So that helps you to get a sense of what you'll often see in some bundles is there's one significant module that's contributing most to a bundle size. And you may decide, can I actually split that module up into submodules in order to make this bundle that we're looking at smaller again? That would particularly apply to the main bundle. You're always trying to reduce the size of the main bundle as much as you can. There is this notion of what's referred to as tree shaking. It really only applies to third-party modules when you're using third-party libraries, which we use a lot in the React app. If the third-party module that you're using supports what's referred to as tree shaking, then you should avail of that in your source code. Now, what I'm demonstrating here in the screenshot is the fact that the Lodash library, I don't know if you are using the Lodash library in the Movies app. It's a library that contains lots of really useful functions for processing arrays and objects, different types of collections. It's a library that has been around for quite a long while, but it's extremely popular. Now, in the early days of the Lodash library, it did not support this notion of tree shaking. So if I can explain what I mean by tree shaking, if you see on the right, sorry, on the left here, I'm importing the entire Lodash module. By the way, that's actually, this underscore is a valid name for a variable in JavaScript, but by convention, we use the underscore character whenever we're using the Lodash library. It's just a convention though. So I'm importing the entire Lodash library, but it turns out that I'm actually only using one function within Lodash, which is this truncate function. So although I'm importing the entire Lodash module, I only need one function within it. Now Lodash, as it turns out, is quite a big module, and I got the figures the wrong way around here. It's actually around 71 kilobytes in size. This should be really referring to this arrow, but I didn't get around to changing it. Now, more recently, the people that maintain the Lodash library, they have they've added this notion of tree shaking to the library. What that means is, if we look over here on the right, it means that I can import a particular function from the library. I don't need the entire library. So when my import statement looks like this, it means that I actually only need around 4 kilobytes from the library as opposed to 71. Now, okay, I'm using static imports here, but if we were to avail of dynamic imports in relation to our Lodash library, then we can significantly reduce the particular bundle that will contain the Lodash library, which would be the main bundle. You know, we're chopping off quite a lot of kilobytes from it. So the message is, when you're using third-party libraries like Lodash, and you are interested in code splitting and all of that, then you should check to make sure that it does support, check to see, does the library support this notion of tree shaking? And if it does, then you can import particular parts of the library in your source code rather than importing the entire library. That's the message. Having said all of that, I wouldn't worry about it. In your case, you should only be concerned with code splitting in relation to our own custom source code, like so the root-based code splitting that I was talking about earlier on. Right. So this is summarizing the last 2 lectures. I'm not going to go over this summary. You can read through it yourselves. So I'm going to leave it at that, and I'll meet you down in IT 119. There is a lab supporting. I'll just go over to Moodle. I think I actually opened up the lab this morning. Yeah, so you can see that there is a lab accompanying this set of slides. And the lab really is working with that, this little app here. And as I said, in the assignment specification, I mentioned code splitting as being a requirement. So once you've completed the lab, you should be able to leverage code splitting in your assignment, although it's something you can leave towards the back end, really. It's not going to have any impact on testing. It's not going to have any impact on CI/CD, any of that stuff. So you can tackle the code splitting side of the assignment at any stage, really. Right, I'll leave it at that, and I'll talk to you in about 5 minutes' time down in the lab room. Thanks.